Today's tricky topic in 2 minutes is torque and center of mass. And I have along with me today, you can see this is a golf club. This is actually a driver that I use when I play golf, which isn't all that often, but I do use it sometimes. So first thing is, how do you find a center of mass of some funny little object like this, like a golf club? Well, I'm going to put my two fingers apart from each other. I'm going to slide them together. And it looks like right about there is the center of mass. And I slide my fingers together until they come to this point. Now, what that means is if I put my one finger right at that spot, the golf club should balance, which it does do. Okay. So, all right, so we found a place where the golf club seems to balance. And what does it have to do with torque and this thing that I called center of mass? Okay. First thing is that this point where my finger is right now is right underneath the center of mass of this golf club. So that's the point where all of its mass can be considered to act. Now, this is a hard idea for a lot of people to get in physics. So if it's hard for you, you're not alone. Okay. But here's the idea. If all of its mass can be considered to act at this point, and this, my finger right now is a pivot point. I don't think anybody would disagree with that. If I wiggle this thing, you can see that it bounces up or down, right? Just like it's its pivot point right there. So the reason it doesn't rotate right now is because all of its weight is right over top of the point of support, which is where my finger is right now. So when the center of mass of something's right over top of the point of support, it's not going to rotate. It's in what we call rotational equilibrium. So if my finger is a little off of this to one side or another, then the center of mass is going to create what's called a torque around that pivot point. So if I move my finger a little bit to the right, my right, of where this is, right, you know which end's going to fall down now, right? Of course it's that end, okay? So why? Well, it's because that center of mass didn't change. But when I put my pivot point over here to the right, suddenly there's something called a torque created. So all the weight of the golf club can be considered to act at this point, and so now there's a weight pulling down and a pivot point over to its right, just a little ways away from it. And what that means is that there's going to be a torque created. A force times a lever arm creates a torque, and that's what causes this thing to rotate the way it does. Okay, so if I put my finger back where the pivot point was, the center of mass was. Right, I'm back in balance now, right? Now everybody knows too, if I go the other way, what's going to happen? Well, how come? What in the language of torque and center of mass and pivot point, why does it happen? If I move my finger over here, now suddenly it drops that way, of course. Why? Well, because now I didn't change the center of mass, it's still where it was. The center of mass is where all the weight can be considered to act, so there's like a force that's straight down, that's the weight of the club that's right over here. And if I move my pivot point over here, see what's created? Again, is a torque, where there's a lever arm times a force that's down this way, and so it can't help but pivot around that point. So the reason it doesn't move in the first case when you have it at the pivot point is because there's no lever arm, really. The force is still there, but it's right over top of the pivot point. So if there's no lever arm, there's no torque, and the thing doesn't rotate. If I move it a little bit over this way, then there's a torque, right? Because I have the same weight, same force, but now it has a lever arm. It makes it want to go that way, okay? And when I put it over here, it goes the other way because now that same weight has a lever arm that creates a torque in the opposite direction.